Look at project 29 here. This is pretty cool. You have to write a parser. And by the way, parsers are real important. You see them everywhere, and they're the source of endless security flaws. There's an incredible number of parsers that don't work right, and there's a way to trick them into doing the wrong thing. This is one of the most common security flaws that exists, is parsers that get confused. So here we're going to make an arithmetic parser. So we're going to give it an expression like this: 1 plus 2 times 3 plus 4 times 5 plus 6. And it's just going to do that math. Now, as you probably know, in computer science, there is natural order to operators. Multiplication and division go first, and addition and subtraction go next. So that's the normal way you would do this. You do the multiplication first and then the addition. But now we're going to change it. We're going to just do it left to right, regardless of the order. So you take 1 plus 2 and add it. Then you take 3 times 3. Then you take, that's 9, so you add 4, multiply by 5, add 6. You're going to do it like that. So that's pretty simple. And so this first thing is don't even, now there are going to be parentheses eventually, but in the first case, just don't bother with parentheses. So this is pretty simple, and I'll just point out a few things I did here. The first thing is, this thing has spaces in it, and you don't need the spaces. So what I also, that's why you have these examples. I start from this one where you know the answer, so you can evaluate the quality of your code. So let me go to my code, and let's just delete this. I sort of dug myself into a hole with that stuff anyway. Let's have a new one. All right, so there's my string. So this is going to be input. I could probably have a better name for it, but that'll do. All right, there. Now I want to get rid of the spaces. So how do I do that, folks? How do you get rid of spaces? Get rid of spaces in Python.
You can use split or strip.
Well, I don't think so. I tried split and strip. It's an interesting thought, though. Let's see what happens if I use split. A equals input split. Okay, let's try that. That's what the AI wants to use. If I split it, well, actually, that worked fine. Thank you. I used your mind. I actually substituted and got rid of the spaces first, but splitting seemed to do it. Great, this did. 1 plus 2. I appreciate it. You're ahead of me. So that puts it in a nice list. So now I have a list with all the items. So now I encourage you to think in terms of the stuff we've been learning. Instead of going through the whole thing, all you're going to do is find something that will do one operation and make it shorter, and then you're going to call itself over and over. That's all you have to do, is make one step towards solution. So you define a function, calculate will do, calculate of string, which is going to be, probably a better name than A would be expression, that's right. A of expression. Okay, and now here I want to do the first mathematical operation. So, and it came in as a list. So this is actually a lot smarter than what I did, by the way. I actually worked from the string, and I had to parse it and find digits and series of digits and then an operator. But this way, I can actually assume that the first item is a number, the second item is an operator, and the third item is the next number. This is actually incredibly simple. So now all I got to do is if expression sub 1 equals plus, then answer equals expression 0 plus, yeah, there it is, expression 0 plus expression 2, but I don't even need to convert them to integers. They're already integers. All right, and else, if it equals asterisk, then it's going to be this times that. That should do it. And what I always do, I only do it, this is actually an important programming technique, you probably know it, never write more than a few lines at a time. Write a few lines and test it. Write a few lines and test it, then you know where your mistake is. Well, the mistake beginning programmers often make is they write 2 pages of stuff. Then, of course, nothing works, and you can't find the mistake. So I just want to print the answer here. So let's print the result. Print the expression. And what I always have been doing lately, which I highly recommend, is I use descriptive variables, and I just print them referring to them by their real name. And then answer. Let's just print answer. That'll do. All right. And now I'm just going to call calculate of expression. And I'm going to make this thing up here that I called input, call it expression. And I'm going to put it here. Oh, I see. All right, let's call that input. Let's call this expression. There we go. All right. There. That's a pretty good start. So the answer is 12. 1 plus 2 is not 12. Oh, it added strings together. Oh, I was not careful enough. It did need the ints here. Okay, I didn't notice they were strings. So I'm going to need the int in front of each of these. The AI was smarter than me. All right. All right, that might do it. Yeah, now I get 3. And now I just want to remove the first 3 items from the list and replace it with a 3. And then do it again. Just call the function again. And so to do that, if you want to make an iterative function, let's finish that. So now I have answer. So new list, new expression equals, okay, the original one was 0, 1, 2. I want to go 3 on, and here I want to add okay, how do you add to the start of a list? I actually don't know how to do that. What I'm going to do is I'm going to do it this way. I'm going to do, you guys may know a smarter way. I'm going to start with string of answer. That's the first term. And then I'm going to do new expression append the rest of that stuff. That should do it. I don't know if you can append a whole list, though. I might have to make a loop of escape, delete. I said, okay, escape to get rid of the AI, then delete. There, I'm going to try this. I'm kind of just dubious that you can add a whole list to a list, though. There. All right. And this has to be inside the loop. This stuff. There. Has to be inside the function. There. Let's see what this does. It's probably just going to crash and burn. Maybe not. Oh, it added it as a list. Okay, so I haven't got quite what I want. I've got all the right items, but I got them in a list. So like I say, you folks might know a smarter way to do this, but the way I know how to do it is for E in expression 3. Yep, then add it. That should do it. Okay. Okay, now I get the new expression. The 1 plus 2 is combined into 3, and the rest is unchanged. So now I've made a function that does one step of the job. And now all I have to do is make this function iterative. So the first thing is, if you're going to do this, you have to make it so it knows when it's done. So if, right, in fact, the AI got it right there. If length of expression equals 1, I keep hitting the wrong button though. There. Okay, if length of expression equals 1, then we're done. We just return the expression. And otherwise, we're going to have to do this stuff and shrink the expression. So let's get this indented. Well, below this line, I need it indented. Okay. Actually, it's indenting by 4, which I don't really like, so I'm going to unindent this with Shift-Tab. There. Okay. So now, this is what it does if it needs to shrink it. And now, what it's going to do, instead of printing new expression, it's going to call itself. So I think it's return calculate. I think that will do it. That will call it again to shrink again. It'll keep shrinking until it finally gets to this point and returns it, and then all of them will return it. Return, going back. So I think that should do it. And so this will be print calculative expression. There, let's see if that works. 71, which I think is the right answer. If you go to the problem, yep, this one's 71. So it goes through these steps. So that's what I mean. That's why I say that's the lesson you've seen in the chapters you've been doing. If you have a problem that's big, just make one step that makes it a little smaller, and then you're done. You should have it notice when you're done and have it call itself. and it will iterate and solve every problem that way, like the Fibonacci is a good example. So that's what I wanted to show you, and there's a variety of challenges with this. So first you do it without parentheses, get this working, and you can do a few of these. Now you got to add parentheses. So you're going to have to make a parser that does the parentheses. Now, this seemed confusing to me at first, but what I did was I just looked through the string for left parentheses and find a matching right parentheses. But what I did was, I think I found, I could have done it a lot of ways, but what I did was I looked for the last left parentheses. Then you know there cannot be another left parentheses after it, there has to be right parentheses. But like I say, all you have to do is find a way to remove one of these anywhere and then iterate until they're all gone. Same logic applies. And so you got those, and then you've got like a nice large database with a ton of them to solve. But once you get the math going, it's all pretty fast. And then you can change precedence. You change precedence so addition is evaluated before multiplication. So now you don't just do them in the order they're written, you have to do the precedence correctly so you get different answers. So that's all. And this I think is good, getting fun, and a good thing to learn. Parsing input is super important and very often goes wrong. This leads to a whole class of vulnerabilities called serialization vulnerabilities. Java does it in many other languages. You can take a bunch of structured data and you can feed it into a serialized object, like a blob of data that you move around, which is easy to send up to the web and store in a cookie and such. But then you have to parse it to figure out what's in there, and there are tons of ways to trick it in parsing it. I think it would be fair to consider zip bombs another flaw here. The zip bombs are an old trick to crash machines. If you zipped data, you have a big file stuck in a small container, so it says the file should be this big, here's the data, you have to unzip it. You can craftily make a zip bomb that will unzip to an unthinkable size, like 1,000,000 terabytes. And so you can't actually make anything that big, and nobody else can unzip anything that big, but it will crash any software that tries to unzip it. And so this is one way, for example, to hide criminal data from forensic examiners, because your forensic tools will try to open the zip files. You can hide viruses from antivirus. Antivirus will try to open the zip files to see what's in there. Many things will try to open the zip files, and if they aren't ready for this, they can do it. There was a German group that made like 30 poison files you could put on your disk that will crash tools people use to examine your disk. There's a bunch of ways to do this. Some of them even happen naturally. If you use Windows for a while, you may have eventually noticed when Windows starts making disk errors, you get a state where there's a folder, and inside that there's another folder, inside that there's another folder, and inside that is the first one. It's an endless loop. This is a fairly common disk error. There's a bunch of things like this that will crash any tool that tries to understand the data on the disk. Yeah?
So you're saying like they could put like malwares, viruses on the zips and try to open it?
Yes, and people recommend this. In fact, this was recommended as an offensive security measure. They say you should put these poison files on your server because it won't hurt your company because no one will use them, but criminals that steal your data will get hosed because they'll try to open that to see if there's stuff in there. And there's a whole book on offensive security where you try to hack back at the criminals. This is generally just discouraged because you're technically committing a crime, but in fact it happens a lot. Microsoft did it. In 2010, when when China hacked all the American companies, and in particular they hacked Google, and Google had just expanded in China and they were really offended. So when they found China hacking them, they hacked them back and stole everything off their servers. And they asked the Secret Service, and they said, that's technically illegal, you shouldn't do that, and Google just did it anyway. And they found that all Americans' data was on there, 30 other companies, Adobe, Microsoft, everybody else's data, and they told them, they hadn't noticed they'd been hacked. Google had the best monitoring outgoing traffic. They noticed, why is all this data going to China? That's not our office. They noticed the data leaving. That's how they found out they were being hacked. Nobody else noticed. But after Google stole all the stuff back, then everybody knew they were all getting hacked by China too. And when Cloudflare faced their first really big denial of service attack that was taking down their whole network, they couldn't figure out how to stop it. And one of their coders came to him and had like 20 lines of C, and he said, well, this will reflect the attack back at the attacker. That would stop it. And so he said, I called my lawyer. The CEO gave a talk about this with me. And he said, to his credit, my lawyer didn't just say no. He said, well, here's the risk. I eventually didn't do it, but we considered it. That's an option. Reflect it back at him. That'll take him down. That'll stop the attack. Of course, you're technically wiping out him and all the people in between you. This is sort of like a cop shooting a machine gun into a crowd to stop the bad guy. It does stop the bad guy, but there are some side effects that you might not want to cope with. Anyway, it does kind of make you responsible for the attack. Anyway, that's why security is an exciting world. You have a lot of these interesting situations to deal with. Anyway, let me check here. Okay, no No new comments in the Twitch. Let me stop this recording.